Hello, everyone. Welcome back to our Hasura live streams. This time around, we're doing it on a Monday. Usually, I stream on Wednesdays. This is a continuation of the live streams for GraphQL January. We've a series of blog posts lined up. We have series of live streams, and this is one of them. I'm excited to launch the new Hasura Advanced tutorial. This went live today. So the stream would be about some of the topics around advanced usage of Hasura. And today I'll be talking about migrations, metadata, and security around Hasura while building apps in production, right? So this is our introduction for Hasura Advanced Topics. We have this course live today, so I'm just posting this link out on chat. Going to go to comments on this tutorial. I've put it on comments. Right. So if you've looked at our Learn courses, we've launched the basics course last year, and this gives you like an overview of using Hasura by creating tables, getting some instant GraphQL APIs out of the box, and trying out a few basic things like setting up relationships, permissions, and the fundamental aspects around role-based permissions with Auth0, setting up JWT, and so on. And finally, you would have set up some business logic with actions and remote schemas. So this tutorial would have covered like the fundamental concepts around Hasura and using Hasura on Hasura Cloud. So today, this advanced tutorial will talk about some nuances around using Hasura. Let's talk about features. Migrations and metadata to start with. And then we also covering performance, how to optimize performance when you're using Hasura, both at the database layer and at the Hasura layer. And we'll also talk about how to improve security. What are the different things to worry about when it comes to security when you're deploying a GraphQL API on cloud, and how to improve reliability, right? So different things can go wrong, and how do you monitor things, and how to improve availability of the services so that the endpoint keeps working continuously, right? And finally, we'll also talk about debugging in this tutorial, different log levels, and how to enable dev mode on the server. So different new things to talk about, to learn about. And today, we're focusing on migrations, metadata, and how to enhance security. To begin with, let's start with migrations. I think we've already talked in the previous streams about applying migrations and metadata using CLI and switching between different environments. So this will be very similar, except that we have like a SQL file that we'll download, and then we'll apply that as a migration file to begin with to seed our initial schema. Then we'll do metadata through the console, and then see how you can export them and so on. So there'll be like different environments where we'll apply this, starting off with local development on my local machine with Docker Compose. So once I have Hasura running on my local machine, I'll apply some migrations, and then I'll use that as my local environment. And to create a staging environment, I'll move to Hasura Cloud, and I'll try to apply some migration metadata that I had on my local machine, basically replicating what I have on my local, and then moving to staging. So we'll see that workflow. Typically, also people use the cloud project itself for local development, for dev, and there are some nuances around that, like how do you configure like your actions, your custom code, and how does a Hasura Cloud project communicate with your local endpoint running on your machine, right? So there are different things to worry about. So we'll go over them one by one today. And the next thing that we'll talk about is security. Um, there's like multiple layers around it. The OSS version has a few things that you can configure, starting from like the simplest of things like setting up a secret, the admin secret, and then configuring auth, and then finally adding multiple layers of limiting responses with rate limits and depth limits in Hasura Cloud. So we'll talk about that, and how you can like configure allow list by automatically looking at the operations that are done on Hasura Cloud. So a lot of easy to apply things using cloud. We'll see how we can take it forward with that. To start with, I'm going to run Docker on my local machine. So I already have like an instance running on localhost 8080. So this is a typical Docker Compose setup that we have usually as a Postgres instance. And there's a Hasura graphical engine instance. This is the latest version as of now, configured with the database URLs. And I also like typically run adminer, like a PG admin kind of a user interface to quickly connect to Postgres. Cool. So this is the service that I'm running. So Docker PS. This is working on localhost 8080. I'm going to open that. To give us the Hasura console running on localhost 8080. This is the server console. There's a difference between the server console and the console served by the CLI. Typically, if you're making schema changes, ideally you should not be using the console served by the server. You should stick to this console served by the CLI. The reason is that if you're directly making changes by adding like a table over here, this change, the schema change, will not be a migration. So you'll not be able to replicate this action onto a different instance easily. I mean, you can always manually create SQL statements and then apply them, but if you're using migration system from the beginning, it'll be easy to like keep a track of the different tables and relationships being created, right? So we'll actually not use the localhost 8080 setup, which is served by the graphical engine server. We'll set up the Hasura CLI to set up a migration workflow. So the first step, if you've not installed Hasura CLI, obviously to install the CLI from the docs. I already have it installed. You have these curl commands which will install it. So I am going to go ahead and then do a Hasura init to create a new project. And I'm going to call this Hasura, and this new project has been created. So I'll cd into Hasura, and this is the usual setup, the directory setup that CLI gives you when you're initializing a project. So I have an empty folder for migrations and seeds. There are no migration files yet, and the metadata files will all be empty. But these are the files which will have the table information and the different kinds of metadata involved with building the graphical API for Hasura. So like metadata around what's there in Postgres, which is in forms of tables and functions, and some metadata about the different kinds of events that have been configured in cron triggers, and different metadata around custom logic code that you've written with actions, remote schemas, an allow list, and so on, right? So all of these files, metadata files, can be manually edited, can be automatically exported through the usage of CLI. And there's also like commands that you can execute to export them. All of these files can be version controlled. So this project directory, this Hasura project directory, is something that you will have in Git. and in version control. Uh, so that would make sure that you'll be able to collaborate in a team, and then you'll also be able to like push changes to a different instance and sync data between different instances, right? So that's the initial directory structure. I have uh, the Hasura CLI set it up. Um, the next step is to actually try out Hasura console through the CLI. So I'm going to do a but YAML. And if you look at the endpoint over here, this is localhost 8080. This would be the endpoint of the GraphQL engine that's running locally. If I do Hasura console over here, this should open up the Hasura console. Let me open it up on my Chrome. This will be 9695. Yeah. So this is the CLI console. And the difference here is that you have this tab called migrations, which is used to say that Postgres schema changes are basically tracked as migration files as you keep changing some schema. So any change that you make through the console, like adding a table or making a modification, all of them will be tracked as a migration file on your local machine. This is possible because you are serving this console through the CLI, which has access to your directories, and it will create the right migration file in the migrations folder as you keep changing some schema. You can also initialize your own schema as a migration file and then apply that to this instance. That's what we're going to do here. We're going to download this SQL file. This is just a schema of the Slack clone that we used in the authentication course. So what I'm going to do is go back, do a wget, and oops, I copied the wrong one, copy the URL, and yeah. So I have the Slack schema.sql file over here. So what I'm going to do is I'm going to do a migrate create, and we have a few commands that you can use. So to create a migration file from an existing SQL file, you can use this SQL from file flag. So what I'm going to do here is migrate create followed by SQL from file followed by the path of the migration file. So this would be Slack schema.sql. And oops, I think I need to give the full path instead of, yeah, I think I need to give the full path instead of the relative one. Work, advanced Hasura, schema. Let me put this in, oops, maybe. And then maybe the full path instead of. Right. Let me look at the docs, which contains the SQL statement, metadata. We're just trying to use the SQL from file. Right. So the other option would be to actually copy the contents of this, and let's go to the console, the SQL tab, and paste it over here. And here we have track this. and also create a migration file for this. This would be like init schema SQL, or maybe I don't want to have the SQL extension over here. I'm going to close this update notification. I'm going to click on run. So this is just basically executing raw SQL statements onto my instance. This is my local instance. So this will be fast, and this SQL has been executed. And we have a few tables sitting around here. Now, if I go back and look at the migrations over here, we have a new up.sql file that has been created. This is from the schema that we copied from the GitHub repo over here. And what has also happened is that since we clicked on track schema, track this statement, which means all of the tables are automatically tracked. What we've also not done is the relationships to be tracked. So what I can do is I can click on track all, which will basically track all of these relationships. And I'm going to click on this, and then I'll show you the metadata that's added to my local directory. So this is track all right now. Once this is done, what we can do is we can head to the metadata directory and do actions. No, we can do tables. This would give us the list of all tables that have been tracked, and this will also have permissions, but ideally right now we don't have the permissions configured. We just have the tables from the SQL statement. So the relationships have been tracked now. We should have this information on the metadata, again part of the tables. So I'm just going to open this, and we can see that there are array relationships and object relationships being configured as part of the metadata. Now, whatever we have changed is already part of the metadata. So if this was a Git repo, you can version control the new files that have been created and modified. Right. So this is my local instance, and I have basically created a migration file from an existing SQL statement, and I've applied it to my local instance. Then what I've done is I have created relationships by tracking all through the console, and I've actually verified that by going to the metadata directory. So this is all done through the CLI console on 9695. If I actually go to localhost 8080, I can see the same. There's nothing different. It's just that this is the console served by the server. The problem with making a change through this by adding a table is that this will not be now part of the migration system. So this will break your synchronization with a different instance. So if you are doing a migrate apply of this, then only the SQL statements until this point will be applied to the new instance, and not the new change that you make through the server console. So generally the recommendation is to avoid using the server console to make any changes. Always use the CLI console to make any changes so that the migrations are being tracked and the metadata are being tracked, right? So that's the first step. We've basically created and applied some migrations in metadata. The next one is to, once we have the migrations metadata ready, the next one is to apply it to a different instance. We'll go to dev environments. And before that, I'll show you how to import and export metadata in case that is something that you might want to do. There are multiple ways to do it. There's one very trivial way to do it. There is one export and import metadata from the console, which gives a JSON file for you, and you can import this metadata as well. And this is just like a JSON structure. The one that we do through the CLI console would be Hasura metadata export. It's just the CLI command, and this would make a API call to a server to get the latest metadata and then modify the right files in the metadata directory, right? Cool. So we have the metadata actions covered, importing and exporting, and we've also tried out Hasura metadata export on the local machine. So this would just sync the data from whatever instance that is this localhost project is connected to. Currently, the config.yaml is connected to my localhost 8080, so this is my local instance. Now the next step is to move this to a staging environment. Now that I've actually made some schema that is ready to be consumed, I want to push this change to a different environment. And the first step is to create a staging environment. And I'm going to make use of Hasura Cloud for that. I already have like a project, which is January-app, and I'm going to cover this, basically apply migrations to this app. Right now, if you open this console, this will not have any data, no schema, nothing. This is just an empty project I've just created off to apply migrations for this. Let's consider this as the staging environment for our project. Now, to apply the migrations, we'll need the project name, the endpoint basically of the project. I'm going to copy that. Now, first step is to migrate apply, followed by the endpoint. And let's say if you are also configured an admin secret, you would also pass an admin secret flag. Right now, with this is not configured, so I'm just going to apply the migrations. This will apply the migrations, the up.sql file that is there on my local machine to the instance on the cloud. There's probably an error on my Hasura Cloud project, so let me actually create a new project. I've deleted the schema and assume that it might work. So I'm try out a new project from scratch. So this is advanced Hasura database. Again, I'm going to click on Heroku. Yeah, pretty instant. So now let me apply this to advanced Hasura. Assuming the project configuration is ready, it's still initializing, so I should have waited. Yes. Right, yeah, different regions, and that's why. Do let me know if you have any questions till now around migrations and metadata. I'll be able to do a demo of those and retry again. This would just create the tables. The migration file will be only about Postgres schema and not about what API can be generated out of this. So the migrations have been applied. The next step is to check out the console. I'll probably close the other tabs. Yeah, I'm going to remove some old values. Those telemetry. Right. Now we've applied migrations. We can see that there are some tables which are not tracked. So this is reassuring because we've created migrations, we've applied them, but we've not applied any metadata. So Hasura still doesn't generate an API for these tables unless we say uh, to track all of these. To do that, the next step would be to do Hasura metadata apply, followed by the endpoint again. So I'm just going to copy that in case I missed it last time. And this time, the API would be created by Hasura because our metadata uh, tells Hasura that these tables need to be tracked by Hasura for generating the graphical API. And these are the relationships that are established between different tables. So all of this information is part of metadata, and that's just getting applied. Now, if I go to GraphQL and see the Explorer, all the tables are tracked and the APIs are generated. So go to data again. If I refresh this, this should give us the tables on the left to browse. We can see that the tables are tracked now. We have channel, online users, and so on. Awesome. So now the migration has been applied. The metadata has been applied from a local instance to a cloud instance, assuming that the cloud instance was a staging instance. Now let's go ahead and make a change on the local host instance so that we can try the synchronization between the two instances again. So I would probably go and add another column to the users table. Let's say the column of type text, and it can be nullable, fine. And do note that I am using localhost 9695. This is the console that is served by the CLI. That means I should have another migration file created. So this is the new file created. This is a directory for the new migration with both up and down SQL files. I can do a migrate apply for applying this migration now. So command would be migrate apply -- endpoint followed by the advanced Hasura endpoint. Right. So now as you keep making changes to the local instance, you will have these migration files getting generated. And once you have like a feature ready for your application, you can do a migrate apply to the staging instance, and then that change would get reflected on this. So let's go to data. We can go to users, and we should be able to see this new column being added onto this table. Awesome. So the metadata is already applied. There's no change over there unless we have some permissions. There's right now there's no permission, so we can skip this. So our new changes are reflecting. We've added a new column, and we can also like start querying that users ID new column. That should ideally come up. We should refresh this so that the introspection can happen. Do the users ID and all right. Let me check the consoles, the users table, and in fact, what I'm going to do is I'm going to do a metadata export from my local machine. Do a git init to just showcase the changes that are happening on the files. Let me do like a git add, git commit in schema so that any more changes we can take a look at. Right. Now I'll do metadata apply hyphen endpoint advanced Hasura. Let's go back to the GraphQL interface. Users, metadata has been applied. Let's click on users. We have ID and we have new column now that we can start querying. Awesome. So the changes have been reflected. We've made a new column on the local machine and we've applied some migrations and metadata to the new instance, and things are reflecting on the API side as well. Cool. The next thing is that if, let's say, you're not using localhost 9695, in fact, if your cloud instance is where your local, in fact, your cloud instance is your dev environment, and you don't have like a Docker Compose or Docker setup on your local machine, and you're actually using the cloud project for development, in that case, there are a couple of things that you want to be aware of. If you're running your custom logic code, for example, your actions or remote schemas or events, that's where you'll have to be configuring a few things correctly. But otherwise, it doesn't matter if you're using Docker on your local or if you're using cloud for your development. Uh, it, it both cases work. The only change is that if you're running your custom code like actions on your local machine, let's say a node server on your terminal on localhost 3000, let's say, then that will not be working directly on Hasura Cloud. So, for example, if I create a new action and let's say my handler is host or Docker or internal, which is to say that I am trying to communicate with my Docker Mac port. Now, if let's say on Linux, you might do localhost 3000 slash whatever endpoint of your action handler is. This will not work, obviously, because the cloud project will not be able to communicate with a local host endpoint on your machine. That the action endpoint that you're running has to be publicly exposed on an endpoint that cloud or anybody can access. For this, I would suggest running ngrok, which is like a tunnel for exposing your local server to a public endpoint. So the way that works is you can do ngrok http followed by the port that you want to expose online. So for example, if I do localhost 3000, I will get an endpoint like this, a public facing endpoint like this fc08 whatever .ngrok.io. This is being forwarded to localhost 3000. And what I can do is in my handler, I can say that HTTP followed by the ngrok project URL, followed by the endpoint that I have, let's say, create user action. So let's follow that as the handler. What this will do is Hasura Cloud can make a request, can make a post request to this endpoint, the ngrok endpoint, which will technically forward to your localhost 3000 running on your local machine. So you don't need to deploy your custom code immediately. You can keep shuffling between different environments and then use ngrok temporarily to keep testing your code and not worry about deploying your code and then keep syncing it back and forth during development. And of course, once you are ready with the endpoint, you will be able to update this to a working production environment URL. And the ideal way to do this would be to use like a environment variable, which would have a base URL as given in the docs over here, and substitute this environment variable with the right value. So in local development, with your node server running on your mission and your cloud project being on on Hasura Cloud, and you want to basically use that for development, you can keep doing that. Everything is the same. You can just configure environment variables with the right values, and things will keep continuing to work. All right. So there's a question by Vaibhav. Is it a good idea to maintain all the DB field migrations with different tool like Django and only the field defaults, custom triggers, and Postgres we use with Hasura migration? Good question, Vaibhav. So this is typically an approach that people take where migrations are maintained at the Hasura level, but it's not mandatory for you to maintain migrations with Hasura. You can use any system, like for example, Django or Rails, whichever gives you migrations out of the box. You can use their system to create SQL files manually and then apply up and down migrations. In fact, our migration system is kind of inspired from Rails. So you can continue to use your own migration system and stick to metadata with Hasura. But the recommendation that I would give is that use Hasura console on your local machine to auto-generate migration files rather than uh, creating migration statements manually, where you will be writing in some custom code for any schema change and then applying them manually. The interesting bit with Hasura is that as you keep using the UI, which is powered by the CLI, with, let's say, the migration is enabled, any change you make, as you saw earlier when I made a change to the users table, I added a new column. That change was reflected as a migration file over here. So that's the benefit that you get out of the box. Both down and up SQL files are automatically created for you. So you don't need to worry about writing this in and the order in which these changes were done. And you also can squash these migrations into a single file if it's getting cluttered with lots of different migration files. In your development environment, you are bound to make a lot of silly changes, which you might not want to version control. When you're iterating a feature, you'd obviously change a lot of things. So once you're done with a feature change, you would want to combine all those files into like a single file, into a single squashed migration, so that your version control history is clean, your file system is clean, and everything is more readable and so on. So you can do that through Hasura Migrate Squash, and hence I would recommend trying out the migration flow from Hasura. But if you're already into a system with external tools like Django or Rails, you are free. You are free to use them. Hasura doesn't restrict you from doing that. So yeah, that's, I think, about migrations. Cool. We've made a change on the schema. We've applied it to staging, and we also saw how we can use ngrok if you're actually using Hasura Cloud for your development setup. The only change if you're using Hasura Cloud for your development, is that your custom code logic, those handlers need to be publicly available. And because your cloud endpoint won't be able to access your local machine endpoint, so use something like ngrok to overcome that and expose that on an endpoint, and then you can keep continuing to work with the cloud project for your development. And don't use your cloud console to make schema changes in case you're using Hasura for the DB migrations. So in that case, you will still continue to use the CLI console. So you will do Hasura console followed by the endpoint, which is the advanced Hasura, basically the cloud project URL that we have here. Just gonna open this once more. Once you do this, any change you make to this endpoint, you will continue to get migration files generated on the UI. Awesome. So that's mostly all about migrations and metadata and moving between different environments. And if you have like a CI/CD setup running, you can auto apply these migrations in the flow, in the workflow. You can do Hasura migrate apply, or you can set up a Docker file, a Docker image, which auto applies migrations on init. So that's the approach that you can take for moving between different environments. And we'll also cover in a different stream when you're moving from staging to production. How do you ensure that there are no breaking changes that are unintentional? So we can cover that in the reliability section of this tutorial. There's regression testing. We'll talk about this next week. And now we'll move on to security for the second part of the stream. We have a few top level features to talk about, um, and and they'll include authentication authorization, which we've generally talked about before. We have lots of resources around this, so I would suggest looking at our basics tutorial, which has covered authentication with JWT. It uses Auth0, but it can be replaced with any authentication provider which supports JWT. And you can also like use webhooks. And the third option is to expose the APIs for public access by setting an unauthorized role. Cool. So I'm going to skip authentication and authorization because we've covered that in one of the previous streams, and it's also part of the basics tutorial. The role-based permission system is something that we've talked about before. So I'm going to skip that and talk about the other less talked about features on cloud and the different security aspects around your production application. For security, the first thing obviously would be to configure an admin secret. So that's something that I'll start off with. Secret. Now, this is a bare minimum that you will do with your production ready app. The next one is slightly different. This is something called an API secret. Let's say you have, let me go to probably actions. Since I've added an admin secret, I need to log in with the right credentials. Cool. Go to data, tables would be there, that's fine. I go to actions. So when I'm creating an action, uh, let's say I have it exposed on my ngrok point. So let's say this is the endpoint, create user, which is a post endpoint. Now, this is an endpoint that you don't want other people to make a HTTP call to, or even if they do, they should be authenticated. Otherwise, you should be able to reject the request. This is because we are accepting these requests for an action or a remote schema. You're sending in a GraphQL query, and for an action, you're getting it as a REST, like a post endpoint, where you're getting this input arguments in a request body, and there can be some headers that can be forwarded from your client. But nothing is stopping you uh, from directly querying this endpoint and making and bypassing the Hasura authorization layer. So to generally avoid that, we'll have like a shared secret between actions, remote schemas or events, bit and Hasura. So let's say you have like a action secret. So I would configure like a header, which is Hasura action API secret, which will come in from an environment variable. And the value of this secret would be shared in both Hasura as well as with your custom server handling the action code. Same applicable for remote schemas and events. Cool. So this is something that you will have to use to prevent unauthorized calls directly to your custom code, and a simple API secret, which is a shared secret, would solve this problem by sending in this particular custom header. This could be any value. This doesn't need to be API secret. This could be just secret key, whatever works for you, and ideally coming in from an environment variable. And the only two services which will know this value is Hasura through the environment variable, and your custom service through that environment variable on that service. And hence nobody can actually call your handler directly. So that's the first setup that you can do to ensure that this is not being called from anywhere else. So that's the API secret. And the next thing is to set up CORS policies. This is kind of uh, important if you're using client-side apps and you're not exposing it for everybody to use your API. So I'm going to add this and show you what that means. CORS domain. So if I do star, it will basically mean that I can allow API calls to be made from any domain on the browser. So let me say that I'm going to allow only example.com, example, and I'm going to add this. Once I do this, I'm going to go to GraphIQL to open this endpoint. So advanced, copy the full one. And I have the endpoint configured. I think I'll also pass in the admin secret required, or maybe I'll pass in a value from collaborator token. Right. If you look at the console, you can see that I cannot make a request to my cloud project because there's a CARS issue. So if I do, let's say, a V1 GraphQL endpoint to this, and enter this, you can see that it's been blocked by cars policy. And my domain is graphqlonline.com is not allowed. So I'm going to make a change to my cars domain to allow that to happen. And I'm going to add graphqlonline.com. And hopefully after this change, I'll be able to make changes to I'll be able to make the introspection through this interface. I'm gonna do a refresh, same endpoint, and I'll need to wait for the changes to get applied. There seems to be a configuration error. I'm gonna refresh this. I'm gonna launch console to just verify if things are working. All right, we have the console running in. I'm gonna refresh this again. Right, so now once I've added this graphqlonline.com, which is like a public interface for trying out graphical APIs. Once I added this domain to the course list, I'm now able to start making queries from this client. Previously, this threw an error saying that restricted course policy. So this is generally useful if you're running a GraphQL endpoint, like making requests to Hasura's GraphQL endpoint from like a front-end app, like let's say a React app or any front-end app, and primarily useful only on a browser scenario. So you can have like a list of front-end front-end apps that are running on particular domains, and then just configure them on the CORS domain environment variable, so that other domains won't be able to like make a JavaScript call from their domains to your GraphQL endpoint. This is one way to secure embedding your APIs on other websites. So that's CORS for you. And of course, with Hasura Cloud, you get SSL and HTTPS out of the box. You have WebSockets also on secure WSS protocol, so that also works. And I don't know if everybody has used this, but you can use the WebSocket connection for not only making GraphQL subscriptions, but you can also use it for making queries and mutations in Hasura. So you can have one connection, one WebSocket connection, which will do all the queries, mutations, and subscriptions from your front end. We'll also like have a demo of this on the Wednesday's live stream, which will talk about integrating GraphQL subscriptions with the React. We did one intro stream last week, setting up the backend and the React app. And this Wednesday, we'll have the second part of it, which will talk about using a WebSocket connection for this. Right. Before moving on, I think we have a question. Joey asks, why doesn't Hasura use Postgres row-level security? Good question. So, so the actual answer is actually when we launched our authorization layer, we were before Postgres row-level security came in, and we had this generic authorization layer at the API layer. I mean, you could have argued that Postgres row-level security would have been a better choice once that was released. But going forward, I think what we've realized is that with multiple services and multiple data sources coming in, an authorization layer on top of all of these services has to be generic enough at the API layer so that you can apply a lot of role-based permission system and not just be restricted to what Postgres is offering, With Hasura now, you can connect to not just Postgres, you can connect to MySQL and other databases in the future. And also, you can already add like remote schemas and actions and custom code that you're writing, which will have GraphQL types. Now you'll be able to like configure permission system generically for all of these types at the API layer. This would not be possible if you're using if you're restricted to just the Postgres row level security. So in a way, the authorization layer route that we took is actually helping us with the current data source that we have, like multiple data sources that you have, and the whole federation story where you have data coming in from different sources and you're joining data between them. And this could be between data in Postgres and data between a microservice. So that's where this API layer works in. Cool. So now the last one around the service level security is the team level access on Hasura console. Um, on Hasura Cloud dashboard, you can have collaborators. You can invite collaborator and make them an admin or make them a user with specific permissions. So if you're giving GraphQL permissions, they can execute GraphQL queries, queries, mutation subscriptions, and access data. If you're giving just the metric permission, they'll be able to browse the Pro tab, the monitoring tab for us to just look at the different metrics and analytics for your project. So this is a layer of security for inviting people to your project and then looking at just the metrics to optimize performance and like monitor good errors and so on. So that's team access for you on Hasura Cloud with different permissions and probably more granular permissions coming in soon. Awesome. So that's the service level security. We've seen configuring API secret, setting up CORS policies to restrict querying from different domains, have a list of specific set of domains that you can configure, just a browser specific restriction, and HTTPS by default, and you have like team access for restricted collaboration between different people on your project. We've already talked about authentication and authorization. We'll skip this and we'll move on to a love list. So on the open source version, we already have like a way to configure a love list. I'll show you that on localhost 8080, which is running the open source version. If I go to settings and there's an allow list tab over here, and I can add an operation manually to a love list and also enable a love list by setting this env variable to true and then start making queries. So to test this out, I'm going to open Docker Compose and to say Hasura GraphQL enable allow list, and that will be true. So the compose, this will recreate. Port is already allocated. Right. I think I've modified the wrong Docker file. So I'll just modify this one. This would be enable love list and be true and compose. And we're done with that. Back to the advanced Hasura. All right, the Docker containers are running. So allow list is enabled. Now we need to add some operations to allow list to enable very specific set of operations to work on. Let's say I want to just allow querying channel. So let me call this fetch channel. I can just say channel ID name and just close these brackets. And let's say I add this to the allow list. So now once you do this, this should be part of metadata. Since we didn't use the CLI console, we need to do a metadata export to sync it back. I'm going to do metadata export. Yeah, so the metadata has been exported. We can actually take a look at that. Metadata slash. I just added allow list, and there's a collection of allowed queries. And if I open query collections, I can see that the allowed queries collection has fetch channel operation with the query channel ID and a name. So this is the only query that will be allowed to be made ideally by the server. So if I make a query to localhost 8080, I will not be able to make any other query. Let me test that out. In fact, I can test this out on Hasura Cloud. So I'll apply these metadata to my Hasura Cloud project. I'm gonna copy this and say -f endpoint. Once I apply this metadata, the allow list will be applied. I have to pass in the admin secret, obviously. So what I'm gonna do is I'm gonna create, move this out to a different tab, modify the change. So the metadata apply. Secret. I'm just basically passing in the admin secret key flag to the CLI. And once the metadata is applied, we can verify that on the Cloud Console as well. So I have finished applying that. I'll come back to my Hasura Advanced, go to settings. Oops, yeah. So I have a love list over here. I have this fetch channel coming in that I've defined on my local machine. Now to enable this, again, I have to do enable allow list environment variable. So go to Hasura Cloud, go to env variable, and add a new env variable, which would be enable allow list to true. So once this is added, the only query that should work is the channel query. I can try that through GraphQL online. Let's say make a user's query. And it says empty, or because I'm passing in a collaborator token. All right, let me try this out. Users ID. All right, so to try this out, I need to actually enable authentication. Right now, if I'm passing in the admin secret, I will be able to make any query. because I'm an admin and I don't have restrictions as an admin. So what we can do is we have to configure auth or some form of an authentication or allow public access for roles. So let me try unauthorized role. Let's say it's public, and let's add permissions to this. Select, have updated permissions. Now the thing with metadata is that you can keep changing permissions or tracking tables and relationships on any console, because it's just one command away from exporting it to your version control. Hasura metadata export will do that for you. Just clicking on save permissions to check if things are changed. Meanwhile, we look at another question from Joey. Supporting multiple databases limit the features Hasura can offer in the future. So the idea behind the support for multiple databases is that, so whatever you're seeing right now with Postgres and Hasura giving you GraphQL API on top of Postgres, it's going to be the same for other databases. So you have like one compiler for compiling SQL statements for Postgres, and the same GraphQL query you can have like a compiler if connected to a MySQL database connected to MySQL. So we are leveraging the database features fully. There's no restriction on creating a middle API layer. So the compiler is written per database. So you are generating, like leveraging all the specific features of each database. For example, in Postgres, you have functions, you have views, you're basically leveraging that. And in case of MySQL, you don't have like multiple schemas. So there are different set of features that you can leverage over there. So, so the feature set is going to be database specific, and all native integrations are supported out of the box. With Postgres, you have extensions being supported. And similarly, it will be there for each database. So yeah, I don't see any feature parity between different databases. After some point, you'll have all the databases easily switchable between different URL strings, and you'll be able to get the same UX around all of these. Cool. Now that I've added this public permission, I'm going to remove this. Query is not allowed. So if you looked at, I've added like a non-authenticated public access env, and I've enabled a love list, which allows only one query to be made, which is the channel query. Now I tried making users query, it's not allowing me. It says validation failed, query is not allowed. So let me try the channel query with the ID and name, and I'm getting a response. Obviously, there's no data, but let's say I'm trying to make a query with created at column. It says query is not allowed. This is because the allow list that we configured initially didn't have this column as part of the query. So the query has to match exactly what the allow list query looks like. So if you have a list of queries with different fields, you have to include each of them separately in the allow list for the queries to work. So adding a new field will not allow GraphQL API to work. Validation will fail. So this is basically what we've tried now. Now this is a manual effort. Obviously, you have to know what are the different combinations of queries that your client will ever make. That's going to be tedious. So in Hasura Cloud, what you can do is you can allow some operations automatically by looking at recently made queries. So I have this introspection query, which typically is made by GraphQL interface. So that's why you can't even look at the schema over here, because the introspection query is not allowed by default. Let me check if this is the introspection query. Yes. Initially, there was the admin secret that was required. Right. So now let me enable the introspection query to the allow list. And once this is done, I'll try making a refresh to the GraphQL interface. Yeah, the change is getting applied. I have made a couple of other queries, which will keep appearing in the new operations tab. As your front-end application keeps making queries, there'll be like a finite set of queries that your app will ever make. Those will start appearing here, and you can select all of them and then add to a love list to be able to restrict the entire query set to just these limited set of operations. This is applicable for even mutations. So as long as it's passing in the right variables, you can add them to another list. I've added introspection now. Just gonna copy this, refresh. And you can see that the introspection, after being allowed, you can now browse your schema on what is allowed for query. And I don't have just channel ID. I should make channel ID name as the query. Let me look at the allow list, and the name of the operation is fetch channel. Sorry, I'll rename this my query to fetch channel. And I think I'm making fetch channel query channel ID name. Let me look at ID name is public. Let's say it's public, obviously will not be allowed. And for some reason, this is still not being allowed. Right. I think it's the query structure over here. Let me try it. Query. So this is the query structure that's added to the allow list. Verify it, and channel ID name should work. And that's what we're seeing right now. So that's allow list for you. With Hasura Cloud, the change is that you don't need to manually keep track of what queries are being sent. You can look at that in the new operations tab from this project. It could be from a different project. Let's say you're running staging production and you have made a bunch of changes to the queries on your front end, and those queries will pop up here, and you can select and then add to a love list. Sorry. So let's look at a question. This is a pro feature only. So this particular feature of automatically looking at the operations and then adding it to a love list is a pro feature, because on the OSS version, you won't be able to keep a track of the number of requests that are being made, and this is a pro feature. On the OSS version, what you can do is you can go to the settings and then add the list of queries that you want to add to the allow list manually, or upload a GraphQL file, obviously, if you know the list of queries. So that's the difference between OSS and cloud. With cloud, you are being given the option to automatically track the list of queries being made. This is stored in cloud and across all projects. So all your cloud projects are synced with, let's say you have multiple instances, you are having operations from different instances which can be synced. This is because you're maintaining projects under your account, and then you'll be able to like sync between different data set. Cool. So done with a love list. We did it through console. We did it through Hasura Cloud. We can also do it through metadata. We saw that over here on metadata. We have query collections. You'll have like a list of queries, and you can keep adding them separately. Cool. So this is a love list, and the next thing is rate limiting, which is another Hasura Cloud feature. So we sorry, we have this API limits on Hasura Cloud, which you can configure based on a few parameters. So let's say you've deployed a production app and you want to restrict the number of queries being made by one particular user, or an IP address, or based on the depth of the GraphQL operation, you can set up some limits. So let's assume that I want to restrict a user to make only probably 100 requests per minute and not more than that. And I will apply this restriction based on a parameter. It can be either an IP address, or it can be like a session variable that I configured. So I can do Hasura, maybe user ID, maybe Hasura some custom variable. So I can configure that. So let's say IP address for now, and the maximum depth of the operation, let's say I can only allow 2, just for a quick example. Let me save. I think I should need to refresh the UI. Looking at the comments again. All right. So going back to configure 100 and 2. And this is for all roles. This is a global rate limit that we have configured based on an IP and depth limit of 2. Make a query. Since I have the collaborator token, I should be able to make any queries ideally. Yeah. So I will start making queries which has more than a depth of 2. I have started from users table. I have channel members, which will have channel ID, and it will have user ID. And we have the relationship for channel as well. Again, to make this query, we can see that the depth has been exceeded. So users is on level 1, channel members on level 2, and this channel is on level 3. So this is the third level of depth that we have crossed. So I have to remove this. So I'm going to remove this depth. I'm going to retry this, and we can see the query is going through. So in a typical production app, you will probably not want the user to make like 5 levels of nesting. And this is only applicable if you are not enabling a love list, because if you're enabling a love list, it's restricted to only the list of queries that you are uh, explicitly allowed to make the query to the server. But if you're not enabling a love list and you're broadly exposing a wider range of queries, then this is kind of a API limit that you can configure. One is basically based on IP or based on some session variable that you have configured, and the other is obviously the depth limit. So if you keep allowing the user to make n levels of nesting, this after a point of time becomes a loop. If you look at the users, I've got the ID name, then channel members, and again I'm looping it back from users and channel members and so on. So making this kind of a query will actually be a performance bottleneck on a database. So if you do analyze on this, the SQL that is generated and the cost of this query will be pretty high. And this right now doesn't have any data, but let's say it has millions of rows. Now making such a complex join query on millions of rows will be pretty expensive. So ideally, you would want to restrict the maximum depth of the query depending on how deep your client is expecting response in a single query. Typically, 2 and 3 depths are fine, but you might want to have a check depending on your application use case, how many levels of depth you want your client to be able to make, and then restrict that on a global limit, right? So that's um, limiting on both uh, parameter based and on depth based. Cool. So finally, there are a couple of things on permissions. So we have response limiting. If you go to the permissions tab for any table, let's browse into data and go to channel, go to permissions. And for select, I can do any constraint, but I can also say how many rows to limit this response to. So I can, at any point of time, given the right number of limited number of rows to be returned back. In case of, let's say you have like millions of rows and you don't want users to fetch in that much data in one shot, you might want to limit the number of rows being fetched at any given time period. So this is one way to limit the response size. Typically used on a very specific use case. You don't want to restrict the number of rows. Ideally, this is if the permissions are configured correctly, you will be able to restrict data fetching in the right way already. But these are also like a feature set that you might want to use, uh, limiting the number of rows at any point of time for a particular role. So this is response limiting. I think this is also typically useful for unauthenticated public access. If you are a logged in user, I think anyway the permission will restrict your data access to whatever you're allowed to, you're authorized to. But if you're like an unauthenticated public access, and you're having like a catalog of products that people can fetch from the front end without logging in, then they'll be ideally be able to make a request to fetch in 10,000 rows in one shot without any limits. So to prevent that kind of an abuse, you can limit the number of rows in the response, and this is obviously like a feature that's it's available on both OSS and cloud. So this is just a permission feature. So you can try this out for limiting the response size. Finally, there are a couple of things related to timeouts. So in Postgres, you have like a database timeout before a statement is executed. You have like a statement timeout setting in Postgres that you can configure about the execution of the statement. In cases where a particular query is taking longer than expected, based on logs and based on the complexity of the query, you can look at that and then configure a timeout in the database to say that if it's taking longer than these many seconds or these many milliseconds, please abort the query and then open up the connection for other queries to work through. This is at the database level. There's also like a HTTP timeout at a webhook handler level. If you look at creating actions, probably not actions, probably remote schemas. When you're adding a remote schema, you can say what is the server timeout when you're configuring a remote schema. So if your graphical server doesn't respond in 60 seconds, uh, the response basically a timeout, and then the other requests are processed. So you can configure this timeout by default 60, but you can configure manually with a better value. Same is applicable for events, uh, both uh, event triggers and cron triggers. With events, you can also set up like a retry if the request is timing out. If it's erroring out, you can have a retry. And this timeout configuration is important because some queries, due to the complexity of the query, might take a huge time to complete. But a series of such queries can actually put down your application. So have a reasonable configuration for timeouts, um, and then just apply them across your instances so that be it at the database layer or at the HTTP handler layer, timeouts are another attack vector. Large timeouts will be blocking resources, and it's important to have like a good timeout configuration as well for all your external endpoints. So that's like a last uh, section of security. We have another question from Joey. Can you set a role limit globally? Adding a permission in every role and every table would be annoying. So the role limit is a table specific configuration and also per role specific configuration. There's no like a global uh, a global permission that you can configure. Um, Typically, it's not recommended to apply it globally because I think the use case would be that if you're logged in, you already have the right authorization layer configured to fetch the right amount of rows. This is mostly, I think, for configuring unauthorized access and trying to fetch in some large amount of data in one shot. And maybe that's when you'll want to restrict the limit. And yeah, that's the use case mostly. Cool. I think that's totally it for today's stream. We're right on time, like 1 hour 30 minutes now. We've looked at migrations and metadata, and we've looked at the different security aspects around running a production ready app with Hasura. We'll look at performance next week, along with reliability and debugging. With performance, we have both optimization at the database layer and also at the Hasura layer. And also we look at caching with Hasura Cloud. So that's going to be exciting. And the Postgres query plans. and also the reliability aspect of Hasura. Again, both at the database layer and at the Hasura layer, having like a highly available system and performing like regression testing to avoid breaking changes when you're migrating from local dev to staging, and the different metrics that Hasura Cloud gives you on the Pro tab, and how do you use this for monitoring purposes, and how do you integrate with different tooling. So that's a reliability, and finally like debugging, different logging levels, and how to make use of the extended error messages in dev mode when you're debugging actions and remote schemas. So that's debugging. So these three topics we'll cover uh, next Monday. Um, to join us next Monday for that. But before that, coming Wednesday, we have the part two of the React live stream. So last week we did the building a full stack app with React and Hasura. We, I think, are at a stage where we've configured a Polo client on React and we've done queries and mutations. The next step would be to configure optimistic mutations and subscriptions and the real-time feed. So to stay tuned for the Wednesday's live stream, and tomorrow we have Adrian joining us to talk about GraphQL with Golang. That will be pretty interesting to look at, and that will be tomorrow. And Wednesday would be the React full stack app that I'm going to build and wrap it up. And that's it from my side for today. Thanks for joining in. And there were good questions on the chat. It was pretty interesting to see. So, to join in for our upcoming streams of GraphQL January. And that's it from my side. Thank you for joining in, folks. Thanks, Aaron, for the shout out. Cool. See you until next time. Bye.